Okay, folks, I am back again. Last one, I think, anyway. I might be wrong. Okay, so we're going to take a look at that last or second to last objective in chapter 10. Dang, dang, dang. This never seems to work right. Let's just try from here. Okay, oh, it is working right. All right, so we're going to talk about designs with more than two independent variables because we've only talked about ones that have only two independent variables for the most part. And we're going to talk about non-manipulated variables because typically in an experiment you're going to have manipulated variables where you change things for different groups, but there are also non-manipulated variables that sometimes occur in experiments, so we'll talk about those. Okay, first, designs with more than two independent variables. You could add the variable of gender to any of the designs that we've talked about. So for example, we could look at in that original physician design, we could put in gender of the participant. Sorry, got my email going on there. So we could throw in gender in the last design to see if women work in groups better than men work in groups, or whether they are getting the easier, difficult tasks easier. So we can throw in gender of the participant, but gender is a non-manipulative variable when you're talking about gender of the participant. And that is because you are not manipulating, you are not changing it. Either they're male or female participants, and that is why it's a non-manipulative variable. Now, if you have a design with more than two independent variables, things can get a little bit complicated because there are three independent variables. There's going to be three main effects. And so there'll be a main effect for each of the independent variables. And then there'll be three two-way interactions in one three-way interaction. So you could have a two-way interaction in between any two independent variables. Because you have three independent variables, you're going to have three two-way interactions, and then you get one interaction that could be between all three. And so when a three-way interaction is when a two-way interaction is different depending on the level of the third variable, and it can get very complicated. We don't tend to do it, and the reason why is because it does get so complicated. And so there's no limit really to the number of independent variables you can put into an experimental design, but it's rare that people do more than two. Because the disadvantage is that it becomes very difficult to interpret. Okay, now I'm going to want you to be able to calculate, graph, and interpret the main effects and interaction effects. So I want you to try it in this video to see if you can do it. So you're gonna have to pause the video and see if you can do it. And then I'll explain it to you afterwards. So if Professor Hyde studies the effects that two or more drugs have on animal activity when the drugs are administered simultaneously. So he's got two different drugs. He's going to see what it does to the activity level of rats and when the drugs are administered together. And so factor A, or the first drug, is there's two levels. So it's either 3 cc's of the drug or 6 cc's of the drug, either a low dose or a high dose of drug A. And then factor B is the second independent variable, and there's either going to be a low dose and a high dose of that too, and that's 2 cc's or 4 cc's. The subjects are rats. The dependent variable is the amount of activity as measured by the number of times they run in the exercise wheel in hundreds of revolutions. So we're going to look at these data then. So here is the first independent variable, and that is drug B, and it's administered at 2 cc's or 4 cc's. And then we have drug A here at 3 cc's or 6 cc's. And what you see is the number of times that each animal ran around the wheel. So this animal got 2 cc's of drug B and 3 cc's of drug A, and it ran once around the wheel. This animal got, again, 2 cc's of drug B, 3 cc's of drug A, and it ran 6 times around the wheel, and so on. So we have 5 animals in this group. First thing we're going to have to do is start by creating a mean for each group. So we need a mean here, a mean here, a mean here, and a mean here. So if you want to stop the video, calculate those means, you can certainly go ahead. Then once we see that, once we see those means, we can look and see whether there's an interaction between factors A and factors B. So I want you to look at the separate means you're getting in each one of these and ask yourself, is there an interaction? Then I want you to calculate the row means in number 3 here. And the column means in number 4. So what you're going to do is take the mean that you got on all these plus the mean you got on all these, add those together and divide by 2 and get your row mean there. Get your row mean here. Then get your column mean here and get your column mean here. And then I want you to talk to me about whether you get a main effect there. Did you get a main effect of A? Did you get a main effect of B there? And then I want you to explain whether there's an interaction. Is there an interaction there? And so you can also go ahead and graph those if you wish to see whether you can graph out that interaction and whether it makes the characteristic cross. So that's the end of this set of lectures. What I want you to do, if you've seen the end, made it to the end of all of these lectures, is take a look at my cat. Let's see if I can get him in the video. There he is. He's sleeping there. And I just woke him up. Hi, Piggy. His name's Piggy. We call him Pigs. And I want you to tell me, did you make it to my cat? And I've got a couple extra credit points for you if you made it to the cat. So please drop me an email and tell me that you saw my cat and it's an orange cat or whatever you see in that cat. Whatever it was doing, just tell me. You guys have a great day and I'll talk to you soon.